This lesson is on section 4.7, titled Similar Polygons. So if two polygons are similar, if their corresponding sides, you can kind of think of the word corresponding as matching. So if their matching angles are congruent, so that word congruent means similar, and their corresponding, so their matching side measures are proportional. Okay, so if two polygons are similar, if their corresponding angles are congruent, and their corresponding side measures are proportional. Okay, so we had to look at similar sides, similar angles. That's kind of, you can kind of summarize that up that way. So let's look at an example. So these triangles right here are similar. Obviously, one triangle is bigger than the other, but what it means to be similar triangles is their angles are the same and their matching sides are congruent, or they're similar. There's some type of pattern that you see. So if we look here, let's color code kind of the corresponding sides. So this side here corresponds to this side here. AC here corresponds to DF here. And BC here corresponds to EF here. Kind of matches up. That word corresponds means matching up. And then if we look at the angles, see these three lines? Well, these three lines and these three lines show that these two angles are the same. These two lines and these two lines show that those two angles are the same, and this one line and one line shows that those angles are the same. So far, the angles are congruent, so that means they check out. So now we got to look at, are the sides congruent? Are they similar at all? Is there some sort of pattern? So if we're going to look at the similar sides or the corresponding sides, we're going to look at first the 8 and the 4. Is there a relationship that goes from 8 to 4? Well, it looks like to go from 8 to 4, okay, it's supposed to be an arrow here, you're going to divide in half, okay? So let's look at this corresponding side and this corresponding side. Well, to go from 10 to 5, looks like you got to divide in half. And lastly, to go from 6 to 3, you also have to divide in half. So if you look at these corresponding sides, they are congruent, they're similar. It's showing that there's a pattern between each side that shows that really all this triangle is doing is we're taking this big triangle and we're shrinking it in half. So that's why these triangles are similar, because there's corresponding sides and there's congruent angles. So for our first example here, it says determine if the following triangles are similar. Okay, so we're looking at angles and we're looking at sides. Now, the difference with this example is that the kind of triangle is kind of flipped around a little bit. So let's color code this just to make sure that we're on the same page with the corresponding sides. So let's first look at the bases of the triangles. So this base corresponds to this base. So I'm going to color code those green, and I'm going to be careful not to cover these angles up. So if you look at, we have these two angles right here, and these, I shouldn't say two angles, just those two lines that correspond with each other. So that means that this side corresponds to this side. And then because these three lines correspond to these three lines, then we know that this side is the same as this side. So just be careful on some examples where they kind of flip around the triangles. The book's trying to trick you, so don't be tricked by that. Okay, so far those angles look like they're corresponding. Let's see if the sides are. I'm sorry, the angles look like they're congruent. So let's see if the corresponding sides are congruent. So if we look at, we can go from small to big here. So to go from 10 to 20, looks like we're just going to multiply by 2. Okay, so if we go from 7 to 14, we also have to multiply by 2. Okay, so finally, if we go from 4 to 8, we also have to multiply by 2. So because we have a pattern, the corresponding sides show a pattern, we can say that yes, these triangles are similar because they have our corresponding angles are congruent, their corresponding sides are congruent. And explaining just means just show me the work. Show me that they have some pattern, that they are congruent. And lastly, we actually have to find an unknown side. So the example says the pair of triangles are similar. Write a proportion to find the missing angle, measure x. Okay, so we're going to be writing a proportion. Proportion, again, are two equal fractions. So because we know that they're similar, okay, we know that these corresponding sides are similar. So we know that these match up. And because we know that they're similar, we can easily make a proportion to figure out this unknown value of x. So what I can do is I can pick any pair of corresponding sides. And in this example, I'm just going to pick the 6 and the 4. So because these sides are corresponding, and because we know it's similar, we can turn this into a fraction. We can say 6 corresponds to 4. Well, if 6 corresponds to 4, we know that 15 corresponds to x. Okay? So we're going to set these two fractions equal to each other. So we're going to say, well, 6/4 equals 15 what? And we've done the fish method, we've done equal fraction method. What I'm going to do is, hopefully this should be a review where I'm just going to reduce the fraction to 6/4 and make it 3/2. And then I'm going to keep this 15x here. So I can say 3 times 5 is 15. So 2 times 5 equals 10. So I know my x has to equal 10. So again, to figure out that unknown side, we first have to know, okay, well, the triangles are similar. And if they're similar, you're just going to pick any one corresponding side and then set it to the corresponding sides with your unknown value of x. And then, you can do any method to solve for x. In the past, we've kind of done the fish method. Remember that method? Or, I use the simplifying fraction method to find an equivalence there. So we know that our value of x is 10. So that is it on my lesson on similar triangles. Thanks for watching.